Okay, welcome to the deep dive.
Hi there.
So today we're diving into a stack of sources you shared, and they're all about this interesting link between math, specifically differentiation, maybe the derivative,
That's right. Stuff you might be looking at in your studies.
and how it connects to something, well, pretty tangible, figuring out the rate of juice extraction from fruit.
Yeah, it sounds simple, right? Squeeze fruit, get juice. But your sources really dig into how quickly that juice comes out at any given moment. It's
Hmm.
actually a practical problem.
Okay, so our mission today is to sort of unpack these notes, see what they really tell us about applying calculus concepts to, agricultural processes.
Finding the math in the real world, essentially.
Exactly.
Yeah.
So looking through this material, the thing that jumps out is this focus on the rate of extraction.
hmm They explicitly talk about calculating the rate juice is yielded for specific fruits, too.
And that word rate, that's kind of a big signpost for calculus, isn't it?
It really is.
When your sources talk about the rate something changes, like juice volume over time, what mathematical tool are they hinting at?
Well, they're pointing straight at the derivative.
Oh, okay.
The derivative, it's the fundamental tool, really, for measuring an instantaneous rate of change. Yeah.
Instantaneous.
So if you graph, say, the total juice you get over 5 minutes,
Uh-huh.
the derivative of that curve at any single point in time tells you exactly how fast juice was flowing out right at that second.
Okay, right. So it's not just I got a liter in 5 minutes. That's just an average.
Exactly.
Your sources are saying it's important to know that maybe at the 2 minute mark, it was flowing fast, like 10 milliliters a second.
Right.
But by minute four, maybe it slowed way down to just 2 milliliters a second.
Precisely.
So why? Why is knowing that specific instantaneous rate so useful for fruit processing?
Well, that's where the practical side comes in, based on these notes. Knowing that instantaneous rate, the thing that derivative gives you, it allows for optimization. Something an average rate just can't offer.
How so?
Think about designing machinery or adjusting it. If that rate suddenly tanks, it drops off sharply,
Mm-hmm.
it might signal that the press needs tweaking or maybe that bit of fruit is basically done.
Oh, okay.
Knowing that rate curve lets engineers, say, fine-tune pressure or speed, maybe even in real time, to get the most juice efficiently.
And your sources mentioned examples, right? Like pineapple and mango.
Yeah, they did.
I wonder if using the derivative shows different like shapes for that rate curve depending on the fruit itself.
That's a really good point. It seems likely.
Maybe a mango, being pulpy, starts fast but drops off quick, whereas a pineapple, more fibrous. Maybe it's a steadier, slower flow.
That's exactly the kind of deeper insight this whole mathematical approach could unlock, based on what the sources suggest.
Right.
By analyzing the derivative, that rate of change, you're not just getting a number. You're potentially seeing something about the fruit's structure, how it behaves under pressure,
So it goes beyond just yield. It's about understanding the process.
the process itself. Yeah.
Huh. It definitely makes the derivative feel less abstract. Calculating the rate of mango juice. That feels different than, finding the derivative of x squared in class.
Absolutely. And this ability, quantifying change right at a specific moment, it's powerful in, well, any dynamic system. Juice, fluid dynamics, populations, markets.
Okay, so pulling this together, what does it all mean?
Well, we've taken this deep dive into your sources,
Uh-huh.
and we've seen pretty clearly how the derivative, a core concept in differentiation, applies directly to calculating something really concrete.
Yeah.
The rate juice comes from fruits like pineapple and mango.
Yeah, it's a solid example. Taking abstract calculus tools and getting real-world agricultural insights. Optimizing machinery, making adjustments on the fly.
It really shows the math isn't just theory. It's like a lens for understanding and, well, interacting with the physical world.
Right. Okay, so as we wrap up this deep dive, here's something to think about. We've seen the power of the derivative measuring instantaneous rate of change in fruit juice. Where else? Where else in your everyday life, maybe somewhere unexpected, might that same idea, that concept of a rate of change, be operating quietly, just waiting for you to notice it?